Hi, everyone. My name's Kirsty. Thanks so much for following along with this thread here. We love the discussion post each week. I appreciate all of your help and contributions to this. So the moment is finally here. I will be talking about mapping urban sprawl in Nashville, Tennessee using the built up area extraction index from 1990 to 2020. So I think most people are pretty familiar with the concept of urban sprawl, but it's generally characterized as low density, haphazard development spiraling outward from urban centers. So this is a problem that both geographers, GIS professionals, and a lot of citizens really are concerned about. It creates ecological problems such as habitat loss and fragmentation, as well as socioeconomic problems such as gentrification from displacement and rising home cost. It also creates increased traffic congestion, air pollution, and really an increased dependence on automobiles since we're so spread out. Um, so while I live in Chicago right now, I am from Nashville. That is home for me. And if there's one thing that I want you to get out of this presentation is that Nashville is more than country music, hot chicken, and bachelorette parties, although one of those three I think is pretty good. But it was previously one of the fastest growing cities in America. And we're projected to add about 600,000 people by 2040. So although we kind of peaked around 2017 to 2019, it's still steadily growing. And that's creating pressure not just on Davidson County where Nashville is, but also the surrounding counties such as Williamson County, Wilson County, and Rutherford County. So those are among some of the fastest growing counties in the nation. And if you're looking at a drive time, some of these are 30, 45 minutes out without traffic, and even some beyond that are growing immensely too. Um, so again, this creates ecological problems, socioeconomic problems, and many other problems as well too. And it's really just stressing the need for smart and climate resilient urban planning, not just in Nashville, but many other mid-sized cities that are just seeing such a growth in population, not just because of the pandemic and people moving out from bigger cities, but this has been kind of an ongoing trend too, especially in the past decade. So looking at some of the modeling and mapping that I'll be doing, my hypothesis is that as time increases, sprawl and built up intensity will increase as well. So moving on to data and methods here. So I downloaded remote sensing data from the United States Geological Survey, Earth Explorer. I'll be comparing 4 different decades here to see how urban sprawl has changed through time. So I'll be comparing 1990, 2000, 2010, and 2020. So from 1990 to 2010, I used Landsat 4 and 5 data. And then from 2020, I used Landsat 8. The water boundary shapefile is from the Tennessee Spatial Data Nexus, and then the county boundaries and those population characteristics are from the University of Tennessee. First thing is just to load them up into QGIS and then just batch clip them to the extent where we can kind of see not just Nashville, but some of those surrounding counties as well too that are that are growing quite heavily. Most of the analysis I did in R. I think it's pretty easy to work with the individual bands and do some of the spectral enhancements and raster calculations in R. So to perform the built up area extraction index, it's kind of a newer spectral enhancement from Zachary et al., kind of an alternative to NDBI or NBAI, but it's really helpful to visualize urban areas because it's able to kind of filter out vegetation as it doesn't really reflect as well in the shortwave infrared band. Um, so after performing those calculations, um, just loaded the TIFF file into QGIS, as well as summarized some of the summary statistics in R and graphed it in Excel. Um, After that, I wanted to characterize some of those differences in the index as well. So to compare 2000 to 1990, 2010 to 1990, and so forth, I extracted raster values that were greater than a 0.15 change just to filter out some of the noise below that. And then created TIFF files from that and loaded them into QGIS and then converted those from raster to vector just to make them pop a little bit more. I initially planned on joining some population characteristics, but that ended up not working out. But after that, I created a GIF just showing how this has spatially increased through time. And then to get into kind of some of the nitty gritty, I also created a web map too using QGIS to web plugin, and then edit some of the legends and fonts and whatnot in R, and then used Amazon Web Services to host the map. All right. So let's take a look at the web map here. And then also if you want, there's a link to the code too that I uploaded to my GitHub. But first thing here on the right is just the GIF that shows the increase in built up area over time since 1990. So again, this is comparing 2000 to 1990, 2010 to 1990, and 2020 to 1990. Sorry. All right. So taking a look here at our map, we have Nashville in the center, and then as well as some of our suburbs here in the east, west, south, and north. I would love for there to be like a nice time lapse here or time feature, but that unfortunately is not what we're working with. So we'll just take a look at each one of these layers as its own. But here's 1990, and then compared to 2000. We see that not only does the spatial extent increase, but also the built up intensity. And again, comparing 2010 to 2000, you see a pretty similar phenomenon as the kind of core city center is getting brighter. Same going on like down here in Murfreesboro in the southeast, Mount Juliet here in the east, Hendersonville in the northeast, Clarksville in the northwest, and then Franklin here in the south. And then lastly, we'll take a look at the 2020 layer. And we really just see it kind of explode here. So we can zoom in, kind of check this out a little bit, and really just identify some of these areas where the intensity has increased over time. And you can kind of flip through these layers and whatnot too, stack them on top of one another and just see how they've changed. So like I said before, not only did the spatially increase, but also the intensity of the BAEI spectral enhancement has increased. So as you can see on in the graph on the right, we see the median and the maximum difference increase as well as the minimum slightly decrease as well, which that could potentially just be a map error, or it could actually show us that there's more reforestation and whatnot going on. But a lot of this growth was really concentrated not only downtown Nashville, but also in the suburbs and then exurbs as well too. So some limitations, accuracy is huge here. Mapping urban sprawl is tremendously difficult because of just the mixed nature of urban sprawl. I mean, you have um, suburbs here where you have homes that are winding through forest with large lawns, and it can be really hard to differentiate homes and roads from just the overarching trees and whatnot too. So I noticed in kind of the northern part, especially of my map, that there was a lot of overestimation on some of the lower values because of the farmland that was there too. Um, so it is difficult to differentiate suburbs from farmland just due to the mixed nature of the suburban areas. Another problem that I kind of ran into was just the QGIS to web plugin. I found it pretty laggy once I kind of loaded up the HTML file. So I was planning on having kind of all my layers there that you could kind of toggle in between, but it just got so slow that I had to remove them. And originally I was going to join some population characteristics so you could kind of compare different areas and see how the demographics are expected to shift. But I think the layers were just too heavy that it couldn't really handle that. So we're kind of left with a more lightweight map, which I think still turned out pretty well. So for future research, there's so much that we still need to learn about urban sprawl, especially as it's encroaching upon some ecologically sensitive areas as well too. But also from just a GIS perspective, I think we could really use different spectral enhancements such as NDVI to remove some of that noise, remove some of the vegetation to really improve the accuracy of this map as well. And also comparing spectral enhancement. So even though the BAEI was very successful for the researchers in 2015, there's no one size fits all approach. Every landscape is different. So comparing a few and then really assessing the accuracy of those maps and then also reducing the temporal time span could really give us some more valuable information as well. Um, Another area of research would just be quantifying changes in habitat loss, gain, and assessing development in ecologically sensitive areas, as well as kind of assessing some of the forest loss here as well too. There's a lot that you could really work here with, especially evaluating changes in socioeconomic status and housing prices in areas where there's high growth as well too. So thanks so much for watching this presentation. I am happy to hear any feedback that you have about the maps or any of my methods or anything. I'm always here to chat and I've appreciated all of your help and all of your insights. So thanks so much for a great semester, everyone. And I hope that you have a wonderful rest of your summer.